Good afternoon. My name is Steve DeBartolomeo, and I'm going to show a new feature that's been added to Smart Die that enables you to select and pass the die outline information precisely to the AIF netlist. You start with a image of our die. In this case we have multiple die, and we're going to clip to the lower left of our die so that that becomes our reference point of 0, 0 in the GDS2 file when we convert it. If we know that reference point and we know the length of this die and the height of this die, then we know exactly where the corners of the die are, and our new feature will center on the die outline and not on the extents of the die pads. I'm going to do that right now by clipping this particular device here. Let's zoom in on it first. I'm going to go to the selection tool, zoom in on this corner. Now I'm going to drag it to the opposite corner. Here we are at the opposite corner. Now I have my die outline selected, and I'm going to crop the image. Now I know where the corners of the die are, at least in pixel space. Now the important thing is to know how large our die is. And since I didn't have that information in advance, I just look at my image size and I see it's 5147 by 3177. We want to save that value and use it when we compute the die width and height. So let's start the process of getting our monochrome image. And to do that, I'm first going to invert the image so that my die pads are in black. Now I'm going to apply a threshold to get those die pads separated from the rest of the data. We go to Image Adjustments, select Threshold. You can see that any pixels above the threshold of 128 are white and any pixels below it are black. Now what I have to do is examine these die pads to make sure there's no short circuits between the die pad itself and the rest of the layout. That'll prevent me from identifying these die pads based on their size and shape. So let's zoom in. We can see right here there's potentially a couple of shorts. And if we continue looking at a different die, we'll see there's areas where there's shorts. That means is the threshold we've picked is not the best one. We need to modify it a little. So I'm going to change it from 128 to say 124. You can see it cleared up a lot of the short there. Let's continue and see if we see anything else. Same areas seem to have a little bit of noise that might act as a short circuit. So we still have two pads up top that might be shorted, and we don't want to do that. So let's go back to those. Perhaps change our threshold just a little more. Right there is a potential short, and over there. So I'm going to change this to 122. And see, that didn't have any effect, so those pixels aren't in that range. We'll go down to 121 now. And that had a big effect. So there was a whole bunch of gray pixels in that area between 121 and 122 that were potentially going to cause a short. So we need to use this value. 121 is the lowest threshold. It gives us no shorts. So we'll click OK. And now we have a monochrome image, although it's still a grayscale image, it just only has two values. So we're going to go to Image Mode and change that from grayscale to bitmap. And I'm going to use 50% threshold, and I'll just click OK. So now I have a 1-bit image, and I'm going to save this. File, save as. I'm going to call it crop to the die edge mono. And we don't care about these parameters. So now I have the monochrome image. I'll be able to run through the rest of Smart Die. Now that we have our monochrome TIFF file, we're going to run Smart Die. We start with a new AutoCAD drawing, pull down Smart Die, and select the TIFF to GDS option. And that'll pop up a dialog where we select the TIFF file we want to process, crop to die edge mono. You need to know the pixel size. I'm going to use 1 micron. The sliver removal parameter, you can set it to values between 2 and 4. I'm going to leave it at 2. We don't need to invert the polarity because we did that in Photoshop. Then we'll jump down to a filtering process where we will use some characteristics of the die pads to remove things that aren't die pads. The minimum width or height is used primarily to remove small items that aren't die pads. We measured our die pads at about 180 microns, the smaller ones, square. So we'll set a lower limit of 150, and anything that has a vertical or horizontal bounding box value of less than 150 will be thrown away. We also measured the large die pad pads and saw that their height was in the order of 500 microns. So we'll set a maximum filter of 600. So anything that's larger than 600 in its extents box will be also thrown away. We can also use these height to width ratio and width to height ratio. A square pad would have a 1-to-1 ratio, and we would set our value a little more than 1 to make sure we didn't throw it out. We have these vertical pads, and they have about a 2.5-to-1 ratio. So I'm going to set the maximum height to width ratio of 3, so those get passed. Anything that's long and taller than that will get thrown away. For the minimum width to height ratio, I'm going to set it to 1.3 because my square pads are a little noisy and I don't want to accidentally throw one away if it's not 1-to-1 exactly. Down here is where the new feature lives. Now if you want to use this new feature, you select Draw the Die Outline. Then you want to enter the precise width and height of the die. There's various ways you can get that. You might know that from the supplier of the die. But if you don't know that and you clipped your die to the exact edges of the die, then you could look at the size of the TIFF file in pixels and then multiply by the pixel to physical size. I had measured 5147 and I had measured 3177. If you recall, my lower left is at 0, 0, and this is the upper right corner. So I know exactly where the die is, and the center will be halfway between these values and 0. Instead of center on center of die pads, which you can do, you say align lower left with GDS2 origin. So let's click Translate. This will just take a second or two. We've generated a GDS2 file from the bitmap. I would like to look at that file before I continue, so I'll say View. I can see that my die pads are one solid geometry and they look pretty ugly, but all we care about is the extents box. These little lines are cut lines into the little holes that exist inside of the die pad. So these holes won't affect our results. Now we'll run Filter. And now we have a new GDS2 file that's been filtered per these rules, and let's look at that. You can see that we got all of our die pads, none are missing, but we got some other things that unfortunately are close enough in size to get past our die pad filters. They have roughly the same extents box and height to width ratios, so we have no way to filter those out. So we will be erasing those in AutoCAD. Now we just click OK, assuming we've got this properly set up. There's our AutoCAD drawing, which was converted from the GDS2. Let's erase some of the things we don't want. If we ID these corner points, you see that that one was at 0, 0. So that's our reference point, and the location of this pad is relative to the lower left edge of the die body. Let's erase these guys that we don't want. Do erase, crossing from there to there, another crossing, and from there to there, from say here to here. So there we have just the die pads that we want. So let's go to the next step, which is pad clean. And it's going to look at all these guys. It's going to find the pads. It says 18 die pads are marked, and you can see that all of our die pads are marked. And at this point we have some filters we can run. We have this filter called sizing. This is really an artifact of our old approach. We don't need to size up and size down anymore. We just leave it at unionize. We just have to run sizing and review. So let's just click here. And now it's going to create a bounding box around each one of those guys, and then it's going to tell you how many it found. It found one pad that's 545 by 292. It found one pad that's 546 by 255. So those two large pads were not the same. And it found 16 pads that are 184.65 by 183.39. We could use those numbers, but we also have this option to redefine this. Let's call them 184.5. And set box size. And now you can see that these 16 are all 184.5. So when I'm done with this, I just click OK. If you zoom in, you'll see that there's the original data which I don't need anymore, and there's the little green box, which I like. I'm going to turn off layer 0, which was the original data, and I've left the green boxes. Those are my die now. Then the final step is to run the die clean module, which will find the centers of the die and allow us to number the die. Then it will export our netlist. Die clean. You need to enter the die name you want. You'll notice that the die outline has already been checked, and these values have been put in automatically from when we define the width and the height of the die. If you look at those carefully, you can see that it's centered at 0, 0. It found 18 die pads. We're going to number the pads clockwise. There's no nets, but we'll make those clockwise too. All I got to do now is click OK. It produced my net list, and if I'd like to see my net list, I click View. So my net list pops up. It tells us when we generated this, units in microns. Here's the name we entered. Here's the width and height we entered, and notice that the center is at 0, 0 using the outline and not the die pad extents. Here's our definitions of the die pads. You'll see there's the square one, and then there are the two rectangle ones. Here's our net list. All right, so that's it, and now we have a proper centered. To show this, I'm going to run this one more time, and this time I'm going to have it create the AutoCAD drawing. So this time I'm going to check this box, create new project and display die, and we'll actually see it on the screen. And we can see now that this is symmetrical about the die outline and not about the extents of the pads. Let's actually show that. What I've done here is I've found the center of the die outline in red, and I've created the extents box for the die pads and found that center in green. And if you zoom in, you can see that two centers are no longer the same, which is often the case. And you can also see, if I do an ID int of this point, that's what's at 0, 0, the center of the die body or the die outline. Thank you very much.